Hello and welcome back to Double Angle Formulas lesson part 2. So far we've looked at the formulas for sine double theta, cos double theta, and tan double theta. Now let's put these formulas to work. First, we're going to look at this simple exercise where we have to express angles as doubles. Very often, when we are searching for exact trig ratios, we will need to express the given angles as doubles in order to find their exact values. So let's get started with 8 theta. So 8 theta can be expressed as double of 4 theta. Now I want you to think where you get the number 4 from. In this case, it's very obvious because number 8 is a whole number and it's a very easy number to work with. But we're going to use the strategy and the idea in the rest of the questions. So when we are expressing number 8 as double of something, practically what we're doing is we're dividing number 8 by the exact number we're multiplying it here, by number 2. So let's move on to the next example. 6 theta can be expressed as double of, again, 6 divided by 2, which is 3 theta. Next, 3 theta can be expressed as double of 3 divided by 2, or 3 over 2 theta. Next, 1/2 theta. This can be expressed as the double of 1 over 2 divided by 2, so 1/2 divided by 2, which is practically 1 over 2 times 1 over 2, or 1/4. So 1/4 theta. Next we have 2 over 3 theta. Again, same idea, double of 2 over 3 divided by 2. 2 over 3 divided by 2, just to show the operation in here, is 2 over 3 times 1 over 2, or 1/3. So double of 1/3 theta. Remember that the more you practice, the faster you're going to estimate these numbers or evaluate these numbers in your head. So last, an easy exercise. 15 theta will be double of 15 over 2 theta. Oops. Here is a better looking theta. So moving on to the next example, we're going to use the double angle formulas to express as a single trig ratio. And then we have to evaluate exactly. So we have to do two things in here. First, express as a single trig ratio. And second, evaluate exactly. So as you can see in here, we have 2 sine pi over 8 cos pi over 8. Two things we have to look for in here. Number one thing is look for patterns. We want to match the expressions with the formulas and see if there is a formula hiding in them. And number two thing, which is very important, is angle consistency. That's what I call it. It's not a math term, but what I'm trying to say is that it is very important that the angles that we see inside sine is the same as the angle you see inside cosine, because that's how the double angle formulas work, right? So 2 sine pi over 8 cos pi over 8 reminds me of the formula 2 sine theta cos theta. So this I know is equal to sine 2 theta. So therefore, I'm going to say that 2 sine pi over 8 cos pi over 8 would equal the sine of double pi over 8. In a more simplified form, this would be sine of pi over 4. Now, as you can see, pi over 8 is not a special angle, so I can't find the exact value of it by simply evaluating this expression as is. But converting it or using the double angle formulas brought me down to sine pi over 4, which is a special angle. And now I'll start evaluating. So I know that pi over 4, or 45 degrees, is in the special triangle, and you can quickly draw the special triangles if that's necessary. So 1 root 2, I hope you've memorized them by now. And sine will be, this is the angle pi over 4, sine will be opposite over hypotenuse, which is 1 over root 2. in a better form or in a more simplified form, we use a process that we call conjugation in order to rationalize, which is considered the more simplified form of a radical expression, into root 2 over root 2 times root 2, which is simply root 2 over 2. So we're moving on to the next question. You can try this on your own if you wish. So first, again, we look for patterns. So the pattern we're seeing here is 2 tan of some angle over 1 minus tan squared. So that means that we are using the tan formula. So we have to rewrite the tan double theta to see if the match is perfect. So we have 2 tan theta for it, 1 minus tan squared theta. And it seems that the right side of the formula perfectly fits the expression. And therefore, we're going to say that this is possibly the formula, but we have one last thing or another thing to check in here, the angle consistency. So we have pi over 6 in both tan terms, which means that we're good to go and express this as tan of double pi over 6. And that would equal tan of, in a more simplified form, pi over 3. Now, pi over 3 is a special angle. As a matter of fact, so is pi over 6, but it would be easier for us to evaluate this expression from its more simplified form than this one here, right? So again, you can build a special triangle, pi over 6, pi over 3, pi over 2. And pi over 6, remember, is 30 degrees. And the dimensions of this triangle are 1, 2, and root 3. We're talking about tan, which means we're talking about opposite and adjacent. So that means that tan pi over 3 will have the value of opposite, which is 1 divided by adjacent root 3. And you can rationalize the denominator, which means get rid of the radical, by multiplying by the conjugate of the denominator, which is root 3. So you multiply numerator and denominator by the conjugate of root of 3, which is root 3, to obtain a radical-free denominator. And when you get a radical-free denominator, we call this process rationalizing or simplifying a radical expression. Now, in example 3, we're writing, it's the same exercise, but we're bringing in more interesting questions, if you notice here, like these kind of angles. So let's get started with 12 sine x cos x. So keep your formulas handy all the time and always look for patterns. The only formula where I've seen sine nx and cos x multiply each other is the double angle for sine 2 theta. And I'll write this down because sometimes when we see things, when they're in front of us, physically in front of us, we can see the connections better. It's sometimes like when you talk to yourself, like when you express your thoughts loudly, you can hear them better. Not all the time, but it happens sometimes, and to me at least. So let's go over 12 sine x cos x. Notice that here we have also sine theta cos theta sine x cos x. But all we need actually for sine 2 theta is a double. So what I am going to do, and I hope you're thinking the same way here, is I will break number 12 down into 6 and then multiply it by 2 sine x cos x. So now I can see better that 2 sine x cos x will give sine 2x, so that would be 6 sine 2x. In the next expression, we have 2 cosine squared x over 4 minus 1. This reminds me of the cosine double angle, which is cos 2 theta equals 2 cos squared theta minus 1. So here I have the exact same thing. So I have a 2, I have a cos squared, I have some angle theta, and I have minus 1, just like in the formula. So which means that this expression must be equal to cosine, that's what we have on the left side, of double the angle theta that is on the right side, which in our case is x over 4. And cosine double x over 4 is cosine of x over 2. Now let's move on to the next exercise. So in the next exercise, we are given cosine theta, 3 over 5, and we're told that angle theta is between 3 pi over 2 and 2 pi. Our task is to find cos 2 theta. So I always start reading solving or answering a question by reading it first. And if I need to read it more than once, that's totally fine. We don't have to understand things perfectly well the first time we read them. And being patient with yourself while you're learning is a big part, or plays a big role in learning a concept and enjoying learning it in the meantime. So we are trying to find in here cos 2 theta, and I'm going to start my thinking process from the question asked, because that's my ultimate goal. And I'm thinking that if I want to find cos 2 theta, I have various options because I know a couple of formulas about them. So first is cos squared theta minus sine squared theta. And then I have the option of 2 cos squared theta minus 1. And another option is 1 minus 2 sine squared theta. And now I'm thinking, let's take a look at the information I'm given. So the information given in this case is cosine of theta. So if I use the first formula, I'm going to need to have the values for sine and cos. Now, when we have the cosine of an angle, we can figure out the other one, the sine of the angle, sorry. But that will require extra work. Not impossible, but more work. If I decided to use 2 cos squared theta minus 1, I can right away use the information given and put it into the formula. For 1 minus 2 sine squared theta, I'm going to think I need to find sine of theta. I don't have it. I can find it from cosine. But that, again, is extra work. So it seems that the best option for me would be using this formula. So I'll write that formula one more time. So cos 2 theta equals 2 cos squared theta minus 1. Remember that when you are answering these questions on a test, you don't really have to go through this process, right? So we're just explaining things for now. But I would start off my solution by writing out the formula cos 2 theta equals 2 cos squared theta minus 1. And now I will think by, what do I have in here? But I want to substitute the values. So cos theta is 3 over 5, which means that, and another thing I want to mention, you probably are confident about how to read and use this term already, but I just want to make sure. So when we say cosine squared theta, it can be sine, it can be tan, it can be any power in here. What we actually mean is cosine of theta to the power of 2. So we are bringing the ratio itself to the power of 2, the whole thing. So which means that when we substitute cos theta by 3 over 5, we're actually squaring 3 over 5 and then minus 1. And that will give 2 times 9 over 25. Remember that exponents come first, right? And you want to try to simplify this as much as possible. It is 18 over 25, the first fraction. The other one is minus 1. But because we want negative 1 to join the first term, which is in fraction form with denominator 25, we want to write it as negative 25 over 25. So we have 18 minus 25 over 25, or negative 7 over 25. Now, I'm happy with my solution, but I want to make sure that this is the ratio that, this is the right answer. So how do I check my right answer? So for this, what I'm going to do is draw the angle theta first. So angle theta, remember, is in quadrant between 3 pi over 2 and 2 pi, so it's in quadrant 4. So in quadrant 4, we have the value of x in here equal to 3. So it seems that if we were to draw the angle theta, it would be somewhere here. So if angle theta is between 3 pi over 2 and 2 pi, then angle 2 theta would be between double of 3 pi over 2, which is 3 pi, and double of 2 pi, which is 4 pi. So let's take a look at where 2 theta would be. So we're going to say that angle 2 theta is between 3 pi, so here's 1 pi, 2 pi, so this is the third pi, and the fourth pi. So it seems that our angle theta will be in the cosine quadrant here. Now, moving on to the next question, we're going to talk actually in more details about this in the upcoming exercises. So we have to find the exact value of sine of pi over 8. Pi over 8 is not a special angle, but I know that I can connect pi over 8 with its double, which is double pi over 8 or pi over 4, because I know that pi over 4 is a special angle. So I must use some double angle formulas in order to find the exact value of sine pi over 8. So being a beginner at using the double angle formulas, what I'm going to do right now is I'm going to write all the formulas that I know of that connect sine pi over 8 with the angle pi over 4. So I will write that sine pi over 4, which is double of pi over 8, equals 2 sine pi over 8 cos pi over 8. Another formula that I know of that has sine in it is cosine of double pi over 4, double pi over 8, which is pi over 4, equals cosine squared pi over 8 minus sine squared pi over 8. And another formula that I know of that has sine and the double of this particular angle would be cos pi over 4 equals 1 minus 2 sine squared pi over 8. Okay, so these are the three formulas that I can use which involve sine pi over 8, which I'm trying to find, and the double angle of pi over 8, which is pi over 4. So let's consider each and every one of them. If I want to use this formula, this will be my unknown. This one I will know because it's a special angle, but then I will have another unknown here, which it is equally difficult to find as the one that I am asked. So I'm going to say probably this is not my best option. Now moving on to the next option, we have cos pi over 4. That's a value I can find exactly because pi over 4 is a special angle, equals cos squared pi over 8, which I don't know what it is, and pi over 8 is not a special angle, and sine squared pi over 8. Now, sine squared pi over 8, I have no problem having it in the formula, that's my unknown, but however, I don't know the value of cos pi over 8, and finding this is equally difficult as finding what I'm asked. So this again will not be a good option. So let's take a look at our last option. So cos pi over 4, that's a value I can find easily because pi over 4 is a special angle. Number 1 is a number, and sine squared pi over 8 is the only unknown in this equation. And that's a value that I'm trying to find. So we're going to say that we have a winner here. This will be the formula we must use in order to find sine pi over 8. So we know that cos pi over 4 equals root 2 over 2. Now remember that you can always use or build your special triangles. Pi over 4 is your 45-degree angle. Again, try to speak radians as often as you can so we get used to them. And the measurements are 1 root 2. So if this was the angle we're referring to, this pi over 4, we'll say cos pi over 4 is 1 over root 2 equals 1 minus 2 sine pi over 8. And I'm going to write this as a power of 2 with brackets and the power outside the brackets. Now we need to solve the equation for this unknown. For some people, it's easier to convert or to replace sine pi over 8 by some letter a, so that, it makes the equation kind of friendlier to look at rather than the sine of pi over 8. Now, if that helps, by all means, go ahead and do so. Another thing that I would suggest we do is rationalize the denominator. So instead of 1 over root 2, multiply by root 2 over root 2, to have a denominator that is not in radical form. So that will make root 2 over 2 equals 1 minus 2a squared. So I would take negative 2a squared to the left side. That becomes positive. And then 1 minus root 2 over 2. Continue simplifying here. You will find this unit very heavy in algebra and calculations. So the more you practice, the faster and better you become at it. So that would be number 1 over 1 can be expressed as 2 over 2. So that would be 2 minus root 2 divided by 2. We still have 2a squared on the left side. So a squared equals 2 minus root 2 divided by 2. And then times 1 over 2. So we can multiply by 1/2 both sides in order to isolate a squared. That will give a squared equals 2 minus square root of 2 divided by 2 times 2, which is 4. Now remember, this is only a squared. We need to find a itself. So we'll say that a equals plus or minus the square root of 2 minus root 2 divided by 4. Now I'm going to stop for a while in here, and I'm going to go into the details of how we simplify this. So this would be plus or minus. So if the whole fraction is inside the square root, it means that we can give a root to both each numerator and denominator. So that can be the square root of 2 minus root 2 divided by the square root of 4. Or even better, plus or minus the square root of 2 minus square root 2 divided by 2. And this would be the sine of pi over 8. So it turns out that sine pi over 8 can have 2 possible values. One positive and one negative. Okay, so why does this happen? And I think that the discussion I started in here will make a little bit more sense. Remember that the angle pi over 8 is in quadrant. The angle pi over 8 is in quadrant 1 because it's 180 divided by 8. So here we go, we have the angle pi over 8. So angle pi over 8 being in quadrant 1 tells us that this angle will have a positive sine ratio. So even though the formula will provide us with 2 different values, so a positive and a negative, we have to be smart in our selection at the end and think, okay, so I got 2 values, but which one would work for this particular angle? And because we know the exact value of the angle, it's not that we are wondering whether it is in one quadrant or the other, so it doesn't have a range. We know exactly where the angle is located. Then we're going to say that our final answer would be sine pi over 8 equals the positive value of 2 minus root 2 divided by 2. So this would be our final answer. We're going to continue the rest of the examples in part 3. Thank you for watching, and I hope this made